Hello, everyone. Let's get started. Today is our last lab, so I will introduce you the laboratory 31. And after that, I will go through 4 different projects for you, give you some hints, okay? So today we are going to learn the classification model. It's totally different from the linear regression model. Because we in the last few, I think from laboratory 28 to laboratory 30, we used 3 examples to show how to construct a single linear regression model and multiple linear regression model, right? But we also need the classification model. Let's see the difference. So here, if we want to, so for instance, if we want to have a model to predict something, to have a regression line, we need to construct the linear regression model. And if we only want to have some classification information, so for instance, if we only want to to determine the values, they are 0 or 1, true or false, positive or negative, or like the final projects, like the right one, so this one good or not. So in this situation, you need to use the classification, okay? So let's see one difference from, let's see one concrete example from this diabetes CSV file. And in classifications, we also use a logistic regression model. For instance, here you learn from the lectures, right? And in this diabetes CSV file, we have 9 columns, right? The first 8 are features, and the last one is outcomes. And you see there are only 2 different values in outcomes. There's only 1 or 0, right? 1 or 0. So, and the previous, the first 8 variables, they are called predictor variables, or you can call it a feature variables. And the last one is target outcome, target variable outcome. Yeah, so that's why here last one would be outcome. So they are only 0 or 1, so means only good or not, good or bad, right? So let's see how to construct a classification model. The first one, as usual, as usual, you need to import the necessary packages, right? And the next one, you need to import the dataset, so diabetes dataset, and you can use this way. You can use the code to rename the column headings, okay? And in this way, you see there are 8 columns and over 700 rows, right? And you can use a head to show the first 5 rows as a simple. And next one, you can use the describe to show the statistics, the statistics of the data set, right? So count the mean value, standard deviation, minimum and maximum. And after that, you can plot the histograms for each feature. This one is the first feature, right? Pregnant. And this one is for the second one. And label is the outcome is the last one. So there are only 2 values, 1 or 0. So that's why here we only have 2 bins. And this one you can also have a fancy figure to show the relationships between the second feature and the outcome, or you can call it a label. Okay. Spot this one. So how to do the pre-processing on the dataset. And next one is how to construct the dataset. So the first one, here we need to select some features. Here we need to divide the given columns into two different types of variables. So first one, you need to select the first 8, right? And the last one is a label. A label would be the target, only one target variable. Yeah. And you need to write. And in this way, we need to split them together. You need to split them into two different parts, the training dataset and testing dataset, right? It's the biggest difference from the multiple linear regression model. In multiple linear regression model, we don't need to split them into different parts. We use all of them to train your multiple linear regression model. But in this way, we need to train them with a part of them and use the rest of them to evaluate the performance. So that's why here we need to split them by using the functions train, test, and split. The ratio here is 75 and to 25. So it means 75 of data will be used to model training, and the rest of them for testing. Okay, so you need to import the sklearn model selection. So sklearn, as that, it is as a basic machine learning models, right? And you can use it to select a function, train, test, split, and set the test size. Okay. And in this way, this CSV file has been divided into 4 parts: xtrain and ytrain and xtest and ytest. Okay. And after that, you can use xtrain and ytrain to train your model. So in this way, we use the logistic regression model and initialize it. Here, please set the iterations. Actually, because the dataset is not very large, you can set like 1,000 iterations. But for larger one, you can set 10,000. Okay. So initialize the data, the model, and fit the model. Use xtrain and ytrain. Okay. And after that, after you perform these 3 lines, you will get a new model, logic regression model. It's called log-reg. Okay, and after that, you can use this way to get the predicted value from the xtest. Okay, so it's different. So for now, it's train complete. Okay, this one is train complete, but next one, you want to evaluate the performance. So please do that again. In this way, because you have a y test, right? They are actual data, and the y predicted data is something is from your model. So the question is how to evaluate the difference, how to show the difference. Okay. Okay, so any questions so far? Do you have any errors? Okay, next one is about how to evaluate the performance. Actually, there is for binary classification, have 4 types of results for true negatives. So it means in y test it's negative, and in y predicted it's negative, and true positive it means they are both positive, and false negative it means for zeros for in y test they are 1 or they are positive, but from your model it is negatives. And for the last one, if the actual data is 1 but your results is different, then so the last 2 they are wrong answers from your models. You need to reevaluate, right? So here is we can use this function. You don't need to write any functions. You can use the functions from the sklearn, and you can get true positive, true negative, false positive, and false negative. And after that, you can choose the false false ones, false positives and false negatives to show the accuracy or F1 score. Okay, so you can use this way. Matrix, and this is true positive, true negative, false positive, and false negative. Okay, so it is a matrix. And yeah, so any questions so far about the confusion matrix? Okay, next one. Here we use only the values. It's not very good. So then we can use a heat map, a colored matrix to show that. So for instance, here you can use the subplots and set the ticks here to show the difference and use the heat map. So the colors means the larger one. And the result is the same, right? Okay, so here is a little bit different because every time you train a model, the training dataset and the testing dataset, they are randomly selected. So the model would be a little bit different, slightly different. So the result would be different in this outcome. So here you see it's 119. It's not 119 from my model, perhaps not from your model. It's 117, and 336 are actual predictions, incorrect predictions. This one is 26 and 13, right? It's not different. It's different. Okay, and next one you can also use the y-test and the y-predicted to calculate all the matrix, like accuracy, precision, and recall. And after that, you can have a report about the classification report. Okay, so it is about how to construct a classification model and how to evaluate this classification model with some matrix. Okay. All right. So and for for final projects for the last one, red one quality is related to today's class. Okay, so I think you have already gone through the background, right? So I only talk about the tasks. First one, you need to do some literature study, and you need to download the data set, and you need to do the pre-process and modify the data set, do some pre-processing, and this one, right? So the classification, you need to use the code from today's class, Laboratory 31, if you choose this project, because it's clear that you need to define a classification algorithm. So it means classify the good one or bad ones. So it's exactly 0 and 1, right? You can use 1 to represent good one, and 0 means the bad ones. So here you need to use a classification model, and after that you need to use a confusion matrix, and this one, and all the scores, recall, precision, all the scores to evaluate this model. So if you don't know how to solve that, please check the codes from Laboratory 31. Okay, how to construct a model, because here you see last one would be the quality. There are some numbers, but you can define it between the 0 and 5. You can define it as bad one, and then it is good one. But it would be a binary classification model. So please make sure to use sklearn, to use logistic, sorry, this one, where is it? regression model. So this one, use this one to train your model and get the model and evaluate, okay? It is about this one. And for the other three, I think they are all about the multiple linear regression model, okay? It's not a classification. For instance, the first one here, the concrete strength, the task is similar, right? You need to describe the challenge, you do the literacy study, and download the database, and describe and reformat. So describe and reformat, you can use the code from here, right? Reformat and code and describe. Okay, and next one is model building. So you need to build a multiple linear regression model and use the R-squared score and RMSE to evaluate the quality. And then you need to define a function to take the inputs from the users and pass them by the arguments. And then to predict, because your model can predict anything, right? So you can predict with these arguments and show the results. Okay, it is about this one, and the instruments is a similar. It's very similar, right? So, but it's a little bit complicated, right? So literacy study and download the database and explore that. But here you need to plot some figures, right? But after that, you also need to build model. Perhaps it's a linear regression model, and use visualization tools to show that red lines, blue dots is about the scatter plots, and the red lines. So we have already done it several times, right? You can check it from, I think, lab that, right? So you can check the results here. Lab 28 and lab 29, and build this one, build a function to take the inputs. And after that, you need to use this one to like predict some values based on your models, okay? It is for the second one. And the third one, this is I think it's pretty complicated because it's a little bit different. You can check the codes, you can check the CSV file from here. Literacy view, sorry. So because there are 3 different features, right? But for 3 different zones, so you need to build 3 different models. And here, let me try to tasks. Literacy study and describe, reformat. You can also find it from Laboratory 2031, right? Reformat and plus, okay? Plus use matplotlib or Seaborn. And here you need to build 3 models to fit the consumption for 3 zones. And for each zone, you need to determine which inputs strongly affect the power, right? So because in Laboratory 30, we have similar situation. In this average house value, we have 8, at least 8 features, but from this figure, we see not all of them have a strong or closely relationships with the average house value. If you build a model on all of the features, it's not a good one. So we need to select some useful features, useful variables. And in this exercise, we only select 3 variables closely related to this one, okay? And it means you need to figure out which one has strongly affected the power. You can use this correlation matrix to figure out, or you can also use the multiple variables model to check the slope of the slopes, right? Some of them, they are very small. And after that, you can determine which one strongly affect the power and build the 3 models. And in this way, you can evaluate all your models, okay? And after that, please build a function by yourself. Using the best models, build a function to take the inputs from the users and pass to the models as the arguments. and use the models to predict the values, all the values. Because they are, so only for the last one, only for the right one here, you need to use a classification algorithm. For the other three, I think you can only use the multiple regression model. Okay. So yeah, so that's all I want to share today. Yeah, do you have any questions about the final projects? All right, so yeah. If you have further questions, please feel free to. No. Sorry. Yeah. You don't need to submit the laboratory 31. So you see here, I don't have a script, right, to let you and from Blackboard, it's not an assignment. I think it's only an item. So you cannot submit. So you cannot submit, right? So here is clickable. It's not clickable. You cannot submit. So it means you don't need to submit. And no labs. It's a last lab. If you have further questions, you can send me an email or you can schedule a meeting with me to talk about your projects or your labs. Okay. And if you have questions about your grades of the labs, you can also send me an email. Yeah, but I think the professor has told you we only select the best 25 grades as your lab grades, right? You have 30 labs, but we only take the best 25 grades. So if you lose some marks on some grades on some labs, it's okay. I think you can also get the 4 marks on the lab sections. Yeah. Thank you. Okay. Any other questions?